is your random fact of the day, guys. Random fact of the day. Alright class, so today we're actually going to go over conditional probability with also some Venn diagrams and some contingency tables. Alright, so if I was to give you guys this term, and it's called, what's the probability of event A occurring when B has already occurred? Okay, now what you're going to focus on here is, let's say if I was to give you a six-sided dice. I mean, I've used that before many times. So let's say if I give you a six-sided dice and I say, how many possibilities do you have in that roll? Right now, obviously, a six-sided dice has how many? 6, right? So that means your sample space, right, or your sample size will equal 1, 2, 3, 4, 5, and then 6. Okay, that is your total sample size of everything that's been happening. Alright, and let's say that in event A, right, you're given these numbers. Alright, 1, 3, and 5. Okay, and in event B, okay, these numbers are located 3, 4, and 5. Okay. Now, what I'm asking you specifically is that what is the probability that what event A will happen given that event B has already occurred? Okay, so what you're going to look at it is as of P, right, of A over B, or A of B, right? A of B. You can look at it like that. And then I'll also give you the formula to solve it as well. But the most important thing what you want to look at here is what 2 numbers or 3 numbers or whatever numbers that are located in part A have in common with part B. Now if you guys can see this here, you'll notice that 3 and 5 are the same in part A and B. Okay, so that's how many numbers? 2 numbers they have in common, right? So there's 2 numbers that they have in common. Right, now how many numbers total is there in general between here and here? Just 3 numbers. Okay, right, and that's the simple way to get your answer. All right, now the actual formula way to get your answer, all right, what you're gonna write is P of A and B, okay, over, okay, P of B. Okay, all right, so now what you're going to do here is all you're going to do is write out what you have in common, right, out of your total sample size divided by what you have in part B in your total sample size. All right, so what do we have in common here? How many numbers do we have in common? 2 numbers, right? So we have 2 numbers in common, right? Now what's your total sample size? Remember, it was 6, right? The 6 is your total sample size. Okay, over, now what do you have in part B? You have 3 numbers in part B, okay, over your total sample size, which is 6. Negative, there we go, 6. Okay, so now what you can do here, you can go ahead and you can actually simplify. Now these 6's will cancel, right? They'll cancel automatically because one's in the numerator, one's in the denominator. But if you want to do it mathematically, we're just going to have to multiply each side by 6 over 6, right, where they cancel. All right, now what you're left with is exactly what you were given here, right? And that is a very simple way for you to understand a conditional probability, that what is the likelihood of event A happening given event B already happened. Now we can go over more examples like this, and I will give you guys some more examples like this just to help you out a little bit, to help you understand. Oh, by the way, another way to write this function for you guys is like this, so you understand what numbers you have in common. So as you can see here and here, you're gonna say A, and it's not the letter N, right? It's just like that, and then B equals, or not equal, yeah, you can say equals 3, 5, right? Which is the numbers that you have in common, which is 2 values, 2 numbers that you have in common. All right, guys. So let me go ahead and give you like a more detailed example of this. Now, mind you, I did write a word problem down for you guys, and it is a bit long. Don't get me wrong. I'll give you guys time to write this down, and I'll read it out for you guys. All right, now let's say there's 500 students in Poinciana High School. Obviously there's more, but I'm just using a smaller sample size of 500. All right, there's 500 students in Poinciana High School. 150 of them are enrolled in Algebra 2, and 80 are enrolled in Chemistry. There are 30 students who are taking both Algebra 2 and Chemistry. All right, now, if a student is chosen at random, what is the probability that a student will be taking Algebra 2? So that's the first part. B, what is the probability a student will be taking Chemistry given that a student is also taking Algebra 2? And C, what is the probability that a student is taking Algebra 2 given a student is also taking Chemistry? All right, so these things you would have to look at in very, very different ways of light. So let me see, hopefully I can get this done on this sample here. Let me see. All right, so let's do this each one by one, okay? So we're gonna draw a Venn diagram, okay? So let me put a circle here. Hopefully you guys can see that circle, okay? And then a circle here, all right? Now, we're gonna say all the kids taking algebra is labeled in the value of A, or letter A. All the kids taking chemistry is in the letter C, okay? And then both would obviously be overlapping in this middle piece here, right? Now, how many students are there taking algebra 1? There's 150 students taking algebra 1. How many students are taking algebra 2, I'm sorry. How many students are taking chemistry? Okay, 80. Okay. Now, how many students are there taking both? 30. All right. Now, how many students are there total? So 500 students total. Okay, so it's kind of going to look like this. It'll look just like this. All right. Now, this is what you're going to draw it as. And now the next thing you're going to do, we're going to solve for A, right? P of A, right? Letter A, we're going to try to solve for. What is the probability that a student is taking Algebra 2? Now, what is our possible outcomes here? You're going to look at it as how many students are actually taking Algebra 2? 150. Okay. Now, what's our total sample size here? Now, it's asking in general. How many are taking Algebra 2 in general in the entire school, right? That's what it's trying to ask you. Well, the entire school is made up of 500 kids, okay? So you're going to take 150, and you're going to divide it by 500. And when you get that, you're going to get, actually, you can cancel these zeros. The zeros are gone, so what you're going to get is 15 over 50, right? Now, you can break down 15 over 50 into a smaller fraction, right? Here's a way to look at it. 15 is 5 times 3, okay? And then 50 is 5 times 10, okay? You could look at it like that. Now, I want to simplify this fraction even more. I can cancel, right? So these cancel, right? So the only thing you're left with is 3 over 10, right? Now, 3 over 10, if you plug it into your calculator, it gives you 0.3, right? If you multiply that by 100, it'll obviously, or you shift your decimal to the right twice, right? You're going to get 30%. So there is a 30% chance that there is a student in Algebra 2 in the entire school. All right, now let's try to solve for part B, where it says, what is the probability a student will be taking chemistry given that a student is taking Algebra 2? Now, what this is telling you here is asking you what is the probability that a student is taking chemistry at the same time as taking Algebra 2? So you have to look at it different. It's not going to ask you, you know, how many total students that are available, like in the whole school. It's breaking it down and telling you to concentrate more on the kids who are taking chemistry as well as taking Algebra 2, okay? So what you're going to do here, you're going to write it as this, P of C over A, and this is conditional probability here, all right? And based on the condition, what they're asking for, right? They're saying that how many kids are taking both Algebra 2 and chemistry, right? There's 30, right? 30 kids are taking both. But given that a student is already taking Algebra 2, well, how many kids are taking Algebra 2? 150 kids are taking Algebra 2, as you can see right here as well. So 30 over 150. All right? Pardon my scribble. All right? Now, you can go ahead and cancel the zeros. The zeros cancel, right? So you're left with 3 over 15, right? Right? Now, you can reduce that because this equals 1 times 3, and 15 equals 5 times 3. 3's cancel. You're left with 1/5. okay? Now, if you know what 1/5 equals, it's 20%, okay? So you can plug it into your calculator, 1 divided by 5, and it'll give you 0.2, okay? Give you 0.2. But like I said, you can either multiply this by 100 or shift your decimal to the right twice out of 100%, it's asking, obviously. And then there is a 20% chance that a student is taking chemistry given that they're enrolled in Algebra 2. Okay, now, what is the probability that a student is taking Algebra 2 given that a student is taking chemistry? So now it's asking the opposite side, right? So if you can catch on by now, it's saying that what is the probability of A over C? Now instead of C over A, it's A over C, right? Now, like I said, how many kids are taking both? 30, right? But now it's giving that, what if they're already enrolled in chemistry? How many kids are taking chemistry? There's 80 kids taking chemistry. Like I said, you can cancel the zeros, and you're left with 3 over 8. Okay, now if you plug in 3 over 8 into your calculator, you get 37.5. So there's a 37.5% chance. Okay, well, if you plug it into your calculator, you're going to get 0.375, right? But like I said, shift your decimal to the right twice or multiply by 100, and you should get 37.5%. There's a 37.5% chance that a student is taking Algebra 2 given that they're already enrolled in chemistry. All right. Now, sometimes if you want, you can round up to the nearest whole number. I won't penalize you guys if you do round up to the nearest whole number in this case, but obviously, if you want to be extremely accurate, yes, I will provide it that would be a most accurate answer. All right. All right, guys, let me give you guys another example here. Now, this is an example with a contingency table, all right, with also some conditional probability inside of it, all right? So let's go over this really long question here. There are 100 students in chorus. There are 30 boys who sing on B flat and 20 girls who sing on B flat. There are 40 girls who sing in C sharp and 10 boys who sing in C sharp. If a student selected at random, what is the probability a student will be A, a girl, B, a boy and sings in C flat, C, a girl given who sings in C sharp? I'm sorry, why am I saying C flat? I'm sorry. Let me reread that again for you guys. There are 100 students in chorus. There are 30 boys who sing on B flat and 20 girls who sing on B flat. There are 40 girls who sing in C sharp and 10 boys who sing in C sharp. Okay, if a student selected at random, what is the probability a student will be A, a girl, B, a boy who sings in C sharp, C, a girl given who sings in C sharp, and D, a girl who given she sings in B flat? Okay, so there's many different ways to look at this function, right? So the first thing we're going to do, we're going to try to tackle part A, right? So what's the probability that a student who sings is going to be a girl? All right, so what we're going to do, we're going to go ahead and draw our contingency table. Now we're going to separate it by 3 different categories, okay? Now you're going to go ahead and separate it by gender, okay? You're also going to separate it by what scale they sing in, right? So you have one with B flat, okay? And then you have one with C sharp. Right? Now, draw your line here. All right. Now we're going to get male, female. Okay. Okay. And then your totals will be at the bottom. Okay. Now, how many boys do we have that sing in B flat? We have 30 boys who sing in B flat. Okay. Okay. So your totals are going to be actually here, and then the bottom here. Okay, so, and then we have how many girls who sing in B flat? We have 20 girls who sing in B flat. How many boys do we have singing in C sharp? 10. How many girls do we have singing in C sharp? 40. Okay, so what you're going to do, you're going to add up your totals this way, and then this way, and this way. Okay, so 30 and 10, that's 40. 20 and 40, that's 60. 30 and 20, that's 50. 10 and 40, that's 50. All right, so what you're going to get over here in this right corner, you're going to get your final total of 100 students. All right. Okay. Now, the first question is asking, what is the probability you will get a girl in general? Like, you select a female, right? So you're going to P of G, meaning girl, right? Now, how many girls do we have total? Okay, females, we have 60 females total. Okay. Now, how many students do we have? I'm sorry, 60. Now, how many students do we have taking course? We have 100. Okay, so I can cancel this 0 and this 0. So you're left with 6 over 10. You can reduce this value, this fraction. All right, both of them are divisible by 2. And if you want me to break it down, I'll break it down here. Okay, you're gonna get 2 times 3, and you're gonna get 2 times 5. This cancels, and you're left with 3 over 5. Okay, now if you plug into your calculator, 3 divided by 5, 60. I mean, obviously you could have figured that out, but 60%, so equals 0.6, right? You shift your decimal to the right twice, or you multiply by 100, there's a 60% chance that a girl will be selected. All right, y'all, let's try to tackle part B here. Okay, now it's asking, what is the probability that a boy will sing and he sings in C sharp? What's the selecting a boy that sings in C sharp? Okay, now remember, this is just specifically asking what's the probability that it will be a boy who just sings in C sharp. It's not, total, he's asking, the question is asking, what's the probability that it will be a boy who sings in C sharp, right? It's not specifically gauging it towards just C sharp itself, right? It's just saying that, oh, this boy sings and he just happens to sing in C sharp. What's the probability of it being a boy, right? So we're gonna get P of B, okay, standing for boy. How many boys sing in C sharp? 10, but it's out of the entire course, okay, in this case. So you can cancel this here, right? You're left with 1 over 10, right? Now if you plug that in your calculator, you get 0.10. All right, you could shift your decimal to the right twice, or multiply by 100, and you get a 10% chance a boy, and he will sing in C sharp. Okay. Next one. Next one says, what is the probability a girl given who sings in C sharp? Now it's specifically narrowing it down, given the fact that they only sing in C sharp, right? It's not saying and she could sing in C sharp. It's not saying and she could sing in C sharp too. So you're narrowing it down just to C sharp now, right? So now we have to look here. Okay, how many girls do we know who are just singing in C sharp? 40 girls. How many girls are there total or how many people are in the C sharp category? Right? 50, right? Girls / C sharp. Sorry, that is terrible. Sharp. Put C on top. Okay, girls who sing in C sharp. All right, what you're gonna get here? We're gonna get 40 and then 50, because like I said, there's 40 girls who sing in C sharp, and there's a total of 50 students who actually sing in C sharp. So what we could do here, cancel the zeros, you're left with a fraction 4 or 5, right? And you know 4 divided by 5 equals, if you plug in your calculator, 0.8. Shift your decimal to the right twice or multiply by 100, there's an 80% chance you'll pick a girl who given that she sings in C sharp. So it's just specifically narrowing it down, right? Now the last one is, what is the probability given that a girl given she sings in B flat? Now we just have to look at the B flat side, right? Now it's narrowing it down just to B flat. All right. So what you're gonna get here is probability of a girl in B flat. All right, equals how many girls do we have singing in B flat? 20 girls. Okay. Now, how many people are total who sing in B flat? 50. Okay. Zeros cancel. You're left with 2 over 5. Now, if you plug in 2 over 5, it equals 40%. But just in case, plug it into your calculator. All right. 40%. 0.4 technically. Shift your decimal to your right twice. Put a 0 there. Or multiply by 100, and you'll get a 40% chance. There is a 40% chance now that there will be a girl given that she sings in B flat. So these are different examples that you guys can use, and I'll probably put two problems up written just like this with different parts, and then you guys do it like that. So literally just be 2 problems, but you'll be solving different parts of that problem on the homeworks. All right. So with that being said, that is your lesson for today. The largest known asteroid is 965 kilometers wide, aka 600 miles wide. Okay, it was discovered actually by the Italian astronomer. How do I even say his name? I don't know. His last name's Piazzi, but his first name's like Giuseppe. All right, in 1801, there was a dwarf planet called Ceres, and that was the first planet and largest, or not first planet. Well, yeah, it was actually a planet at that time. Was the first and largest object to be considered an asteroid. All right, it is located in the asteroid belt between the orbit of Mars and Jupiter, and accounts for 33% of the entire belt's mass. Yes. Significant Whizzlebits. All right, you guys have a wonderful day, and I will see you guys there.
What's good? Yo, dog, not astronomy, man. An astronomy attack.